Have you ever played on a seesaw at a playground? Imagine a 30-kilogram child sitting on one side and a 60-kilogram child sitting on the other side. If they sit the same distance from the middle, will the seesaw balance? Of course not. The heavier child will go down and the lighter child will go up. To make the seesaw balance, the heavier child has to move closer to the center. Why? Because the heavier child has a greater influence on the balance of the system. The same idea helps us understand the center of mass. The center of mass is the balance point of a system. If one object is heavier than the other, the center of mass will be closer to the heavier object. To calculate the center of mass of two objects on a line, we use this formula. Suppose a 2-kilogram object is at position 0 meters and an 8-kilogram object is at position 10 meters. Substituting into the formula, so the center of mass is at 8 meters. Notice that the center of mass is not halfway between the two objects. It is much closer to the 8-kilogram object because that object is heavier. Let's do one more example. A 3-kilogram object is at position 2 meters. A 9-kilogram object is at position 14 meters. Using the formula, again, the center of mass is closer to the heavier object. So here's the key idea. When two objects have equal masses, the center of mass is exactly in the middle. But when one object is heavier, the center of mass shifts toward the heavier object. The heavier the object, the more it pulls the center of mass toward itself.